Hi, this is Dr. Payne, and what I'm going to go over with you is the skeletal system. I'm going to go over some highlights. What I'm going to review is not an all-inclusive list, but it, excuse me, it goes over some of the highlights and issues that most students have when they are studying the bones. And I've attached a document to this email to give you some tips and mnemonics to help you memorize the bone markings. We're going to start with the skull first. And so some of the tips for bone markings uh, for the skull, first of all, for the skull, when it comes to paired cranial bones, you will need to know right side from left side. When you're identifying these, it will be identifying, for example, the parietal, whether it's right or left, temporal, right or left, and all the other paired bones, the nasal, the maxilla, mandible, zygomatic. You'll be presented questions about right and left as the skull is as a whole. So these won't be taken apart. You actually have the whole skull in front of you and basically just know the right side from the left side. When you're studying the skull, you need to study it from all orientations. So from the front, the lateral side, and also the inferior side and the floor of the skull. So here are some of the paired bones here, basically left and right. And in your lab manual, you'll have a list of those paired bones, and it will say left and right next to it in the lab manual. Okay, let's look at the inferior view of the skull. I'm going to zoom in here. So from the inferior view of the skull, some of the landmarks that you need to know are the mandibular fossa, which is located here, the occipital condyles, which are these large bumps that articulate with C1, or another name for C1 is the atlas, the styloid process of the temporal bone, which are these pointy sharp edges here, and the foramen magnum, which is the largest hole of the skull. When we look at the floor of the skull, it looks a little bit different. This is looking at the inside of the skull, and the calvarium has been removed. Some of the structures here that are most commonly seen on the exam and also that give some students some issues is the sella turcica, okay, which is located here. And then also your foramen magnum can also be seen from the floor. And then the cribriform plate versus the crista galli. The plate is located here with the little holes in it. And then the crista galli is this structure right in the middle. This is part of the ethmoid bone here. The cribriform plate sits superior to the nose, so it's on top of your nose. This is where you have all the nerves that are responsible for the olfactory or sense of smell that you'll learn when we'll get to the nervous system. Also on the floor of the skull, you'll need to know some foramen that are lateral to the sella turcica. Okay, and these are the foramen here, and let's zoom in. Ooh. Okay, and the mnemonic for those is ROS, and you can add J. On the attachment that I have to this email, the mnemonic is round opals, sparkling jewels. So you have your foramen rotundum, then your foramen ovale, and then spinosum, and then you have your jugular foramen. So that's your ROSJ. Those are the ones that you're responsible for the floor of the skull. Next, we're going to move to the vertebra. Okay, and let's zoom out. I stated on your review that you need to be able to differentiate between the cervical vertebra versus the thoracic and lumbar vertebra. So you may have one sitting on the table and you need to know not only which vertebra it is, but also all the markings of the bone markings of the vertebra. So this is just a vertebra in general. Okay, and this is figure 8.17. This is a thoracic vertebra. And these are the bone markings that you're responsible for as far as the vertebra. So make sure you know things like the superior and inferior articular facets. You need to know the spinous process and transverse process. The spinous process runs anterior to posterior when it's sitting in your spine, in your actual body. Then you have your transverse process that runs horizontally or transverse. Okay, and then another structure that you're responsible for is the body. Now, when you look at the spine, you have 7 cervical vertebrae, 12 thoracic vertebrae, 5 lumbar vertebrae, and then your sacrum, you have these segments, and then your tailbone, which is also your coccyx. When you look at the attachment that I've attached to this email, you'll see one way to remember 7, 12, and 5, 7 a.m. breakfast, 12 noon lunch, and 5 p.m. dinner. It's just a little mnemonic to help you remember how many of each there are in your spine. Okay, let's go down. Okay, so table 8.5 helps you to compare the cervical vertebra from the thoracic and lumbar. As you go from cervical to lumbar, you see the body of the vertebra changes. The thoracic vertebra, the thoracic cavity holds the heart, so the body of the thoracic vertebra kind of mimics a heart. This would be an upside down heart. And then here you have the lumbar vertebra, which is the biggest one. The shape of the lumbar vertebra are said to mimic a moose's head. And then the cervical vertebra would be the smallest. Two other structures that you're responsible for are the atlas and the axis. This is your first cervical vertebra and then your second cervical vertebra. One thing to note is that your C1 does not have a body. Your C2, a distinguishing characteristic, is this structure here called the dens. So C1 sits on top of C2, and the dens allows the atlas to rotate, as you can see here when you're turning your head right and left. Okay, when we move to the thoracic cage itself, what you need to be able to differentiate are your true ribs. These are called true ribs because they attach directly to the cartilage that goes straight to your sternum, okay, which is your breastbone. Your false ribs, which are 8 through 12, they attach via cartilage that attaches to the cartilage of the true ribs, and then it goes to the sternum. That's why those are called false ribs. Now, 11 and 12 are your floating ribs. These are special false ribs. Okay, they're considered to be false ribs, but specifically they're floating ribs because they do not attach via any cartilage. Okay, when you're studying the rib itself, you do need to know these structures and look in your lab manual so you know which ones specifically you do have to know. And make sure you go over figure 8.21 when you're reviewing the ribs. Okay, so now we're going to move to the appendicular skeleton. And here we go. Okay, so first bone in the appendicular skeleton, this is your humerus. This is the arm bone. What you need to be able to know on your appendicular skeleton, there's two bones that you will need to know, right and left, but we'll go over that in a second. But you need to know anterior from posterior. The reason you need to know the front of the bone versus the back of the bone is because certain bone markings that you're responsible for are only located in the front and some are only located in the back. Two structures you need to know firsthand is your anatomical neck of the humerus. It is located right around the head of the humerus. And then as you get further down, you'll see what's called the surgical neck. So one's located around the head and one is further down, okay? Another structure you need to know is your greater tubercle, and another one is your lesser tubercle. So when you're looking at the humerus, what you'll see to differentiate between anterior and posterior, one landmark are these tubercles. You can see these, you can see both from the anterior view. Another structure you can use is the olecranon fossa. This is where the ulna will articulate to form your elbow. This olecranon fossa is located in the posterior view. It's very, very deep. When you're trying to differentiate right and left, the heads always point medially. That's how they sit in your body. So right here, you can see how the humerus articulates with the radius and the ulna. The head of the radius, you'll see here. And then you have the hook shape of the ulna that's going to hook into this olecranon fossa so you're able to make a hinge when you're bending your elbow. Okay, the next two structures are your radius and your ulna. In anatomical position, your radius is lateral and your ulna is medial. The olecranon process is here. That's the hook that hooks into the olecranon fossa of the humerus. And then it's important to note that the head of the radius kind of looks like a hockey puck. It's more proximal. Two other structures you need to know are your stylus, or styloid processes. One of the tricks is that, remember that a stylus that you use to write with, you use your forearms to support the writing. So you have your styloid process of your radius and styloid process of your ulna. Here's another important thing to note too. Both of these bones have what's called a head, okay? The head of the radius is more proximal, but the head of the ulna is distal. Okay, moving on to the wrist. So what you need to know are your carpal bones. In anatomical position, you see your thumb is lateral, okay, and your pinky finger is medial. So when you're going to study for these carpal bones, you're going to study them from lateral to medial. There's two rows in the carpal bones. This is the first row. This is your proximal row. Then you have your distal row is located here. When you're in the Science Learning Center and you're looking at these structures, you're going to see that the pisiform sits on top, okay, of the hamate. Okay, so here you can use the mnemonic straight line to pinky. Here comes the thumb. So straight line to pinky. Okay, and then here comes the thumb. When you look on your attachment file that I have as tips, you'll see the way that you need to memorize it. When you're looking at these, like trapezium, the trapezium is on the distal row, and trapezium is under the thumb. The scaphoid is also associated with the thumb. Okay, now as far as knowing right and left, you will need to be able to differentiate between the right os coxa and the left os coxa. Okay, and this is the word os coxa. So when we move to this figure, which is figure 8.29, the giveaway to let you know what's anterior and posterior is this big notch here. This big notch is the key to let you know that everything on the back part of the os coxa is posterior, and we'll have the name posterior here. And then the anterior part will be located here. There's three parts to the os coxa. You have your ilium, which is this big wing-shaped area. The ischium part, that's where you actually sit. And then you have your pubic part. So when you put two os coxa together, that's how you get your pelvic girdle. So there are structures called the anterior superior iliac spine and the anterior inferior iliac spine. Because it's located on the anterior part of the os coxa, they're going to have the word anterior in it. Okay, this is superior and this is the inferior. In contrast, you have your posterior superior iliac spine and your posterior inferior iliac spine. This is the great sciatic notch. This is where your sciatic nerve goes through when it's sitting in the pelvis. Okay. This structure shows your pelvic inlet, okay, which is in blue, and then your pelvic outlet, which is in red. So basically, this portion where you have this big hole, when the first section as you enter the hole is called the inlet, and then the part where it exits the hole closer to your tailbone, that's the outlet, hence the names. Okay. Now, okay, so I'm gonna zoom out. Okay, so the next bone is your femur. Kind of looks like the humerus, but it's way bigger. The femur is the largest bone in your body. It's very, very hard to break this bone. But as you can see, like the humerus, the heads of the femur go medial. Now, to know anterior from posterior, when you look at the posterior part of the femur, you'll see this ridge. On the anterior part is smooth. So the key to let you know what's posterior is this linea aspera, which is this ridge. Very important structure for the attachment of the hamstrings. The other structure you need to know is this greater trochanter. Okay. And then make sure you know your medial condyle, lateral condyle, and your medial epicondyle and your lateral epicondyle. These condyles are important for articulating with the tibia. Okay, when we move to the tibia and the fibula, let's zoom in. So first you have the tibia, which is your shin bone, and then you have your fibula. So the key to know what's the anterior part of the tibia is this bump that's right under your kneecap. That's called the tibial tuberosity. That's the giveaway that that's the front. Okay, and then you have your fibula. You are responsible for knowing your tarsal bones. A mnemonic is cow told Nate milk is like cream. So you have your calcaneus, which is another name for your heel. It's the largest tarsal bone in your foot. Then you have your talus, okay, which is located here. So this picture is the superior view, the top of your foot. This is the inferior view from the bottom of your foot. So your talus sits on top of your calcaneus. Then inferior to the talus is your navicular bone. And then you have your cuneiforms. You have your medial cuneiform, a cuneiform that's between the medial and the lateral, which is your intermediate cuneiform, and then your lateral cuneiform. And the last tarsal bone that you need to know is called the cuboid. So your cuneiforms are medial and your cuboid is lateral. So those are the tarsal bones that you're responsible for. So that's pretty much a summary of the bones and the bone markings. Again, I didn't go over everything, but those are the major structures that you're responsible for. If you have any questions, send me an email. Be sure that you go through your lab manual and you follow all the lists that are located in the lab manual for your bone markings.